Okay, today we are going to look at lesson 1.4 on our subtracting integers with modeling. Again, not looking at just how to subtract integers. What we're learning is a different way to actually model and explain to others and prove our answers. So, first thing I always ask people is if I had an addition worksheet and I had a subtraction worksheet, and there was 100 problems on each. If you didn't get penalized for picking one over the other, which one would you pick? And almost everyone says they would pick, if they had to, they would pick an addition worksheet over subtracting. And when you ask why, well, it makes sense. You've been adding a lot longer in your lives than you have been subtracting. But what I want to let you know is subtraction actually means to add the opposite. Subtracting is just adding the opposite. So we can actually change any problem, any subtraction problem, to an addition problem. So when I look at this one right here, 3 minus 5, I know that that subtraction sign actually means to add. I'm going to change it to adding, and I'm going to change that next number to the right of it to its opposite. So when I rewrite a subtraction problem, the first integer doesn't change. That's 3. Subtracting actually means to add the opposite. And the opposite of this number right here, opposite of 5, is negative 5. And then we have worked with modeling addition in lesson 1.3. So when I go ahead and say, okay, well, show me, model for me 3 plus negative 5, you would say, well, that's positive 3. And, well, I should probably make that open because we make those open here. Positive 3 light or open counters, and then negative 5 closed counters, and then looking at those opposites that cancel each other out because they're additive inverse, they make 0, shows me that I'm left with 2 negative counters. So my answer is negative 2. So 3 minus 5 actually means 3 plus negative 5. And then how I model it is exactly the way I modeled it in lesson 1.3. So now that's what we're going to be working with, is modeling and showing our subtraction problems. So with number 1 right here, and I gave you those steps right next to it, if you see a subtraction problem, I actually want you to rewrite the expression as that addition problem, the adding the opposite. So I see a subtraction. I need to circle it to know I'm going to change that to adding, and the one I'm going to make the opposite is the one to the right. So let's rewrite that problem. That's exactly what I want to see you doing. Equals, and now change it to an addition problem. This means 2 plus an opposite of negative 4 is positive 4. And now we are going to go ahead and draw the number of counters to model this for that first integer. And remember, when we're modeling, our positives are our open circles, our negatives are our colored in or darker circles. So let's go ahead and do this one. Positive 2 is 2 open circles. Now, step 3, we're going to draw the number of counters we need for that second integer, and that second integer is positive 4. So I need 4 open counters. Now canceling out any pairs of opposites or additive inverse, which I don't have any opposites, they're all positive. which means I'm now going to go ahead and just total up how many I've left. I have all positives, and I now have 1, 2, 3, 4, 5, 6, 6 positive counters. So my answer is positive 6. So 2 minus negative 4 is actually the same as 2 plus 4. And again, I know you know what 2 plus 4 is, but again, we're modeling. You're proving it to me, not just giving me answers. So let's go back and do B. Again, I do see a subtraction problem, so I want you to change this to add the opposite. So let's rewrite what the problem actually means. Negative 3 minus negative 5 means negative 3 plus add opposite of negative 5 is positive 5. So you're rewriting that problem as an addition problem. Now let's get our counters going. My first integer is negative 3. That's our colored in circles. So I'm going to go ahead and, I like to use my highlighter to do it because it's already nice and colored in for me. 1, 2, 3 of those counters. And now my next one is a positive 5. Well, that's open, and now I need 5 open or lighter counters. Now what I'm looking for, since there's no other integers, is I'm looking to see those additive inverses, those opposites. Because opposites, when you add them together, turn to 0. So I'm going to cross those out because those are my 3 sets of opposites. The only thing I have left now are 2 counters, and they're both negative, so my answer is negative 2. Let's do one more, and that's 7 minus 9. Again, rewrite any subtraction problem as add the opposite. So let's rewrite it. This becomes 7 plus, and opposite of 9 is negative 9. So now let's go ahead and draw those counters for that first integer of a positive 7. So we have 1, 2, 3, 4, 5, 6, 7 positive counters. And then we're going to go ahead and get 9 negative counters. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's look for those pairs of opposites. Oh, these are definitely opposites. So I'm going to cross those out, and what I have left are 2. Oh my goodness, you know what I did up on number B? Why didn't you stop me? This isn't negatives, those are positives for a B. Oh, I can't believe I did that. I'm glad you caught me. Positive 2. I don't know what I was thinking. That was positive 2. So I made a mistake on that one. That'll be the first time and only time I make mistakes, so don't ever say anything about it again. Okay, now let's look at what we have on this C. There are 2 counters, but these are the colored in. These are the negatives. So it is a negative 2. Negative 2. Now we're going to do another one in class, that D, so let's leave that one blank. But I want to look at, what if I asked you to do it using integer tiles instead of counters? Well, your steps are going to be the same thing. When you see a subtraction problem, I want you to change it to an addition problem. So rewrite it first for me. That would become 5 plus, opposite of 4 is negative 4. Now here's the difference. When you're doing integer tiles, you don't use the round counters. You're using your positive and negative signs. So my first integer is a positive 5. So I want 5 positive signs. Those are called integer tiles. My second number right here is negative 4. So I want 4 negative tiles. Now remember, the only thing is, When I'm using integer tiles, we do not cross out or cancel out the opposites. We circle them. Otherwise, we turn those negatives into things that look like positive, which they're not. So I'm going ahead and just circling those opposites, circling them because they're becoming big zeros. They cancel out. Now, this makes it very easy for me to see exactly the fact I have one positive left. So my answer is +1. Those are some ways we can model with pictures. So if I said, prove your answer to me with counters, you would use those circles. If I said, prove it to me using integer tiles, you would do those positive and negatives. And again, it's not about can you get the right answer just in your head. It's a different way to prove it mathematically using some diagrams. So that's your lesson 1.4, and we will be working with those in class. Have a good day, and I will see you soon.